Now, question number 4 in the worksheet. You're given the function xy, and it's x cubed, y cubed, 3x squared, 3y squared, minus 8. And you want to find the maximum, minimum, relative, all that. Okay. First, we find the derivative with respect to x. That's 3x squared, 6x. And we find the derivative with respect to y. 3y squared, negative 6y. We set both to equal 0. If I take the first one, I can take 3x common factor. That would leave me with x plus 2. Meaning that either x 0 or minus 2. If I take the second one and take 3y as a common factor, then y is 0 or 2. So possible points are 0, 0, 0, 2, minus 2, 0, and minus 2, minus 2. So after you do this, we need to verify, are these points maxima, minima, saddle points? To do this, we need to find 3 things: fxx, fyy, fxy. The derivative for this with respect to x, again, would be 6x6. The derivative of this with respect to y, 6y minus 6. The one we did with x, we do with y, and everything is a constant, that's a 0. So now we test all 4 points. So I'm going to test point 0, 0. What's fxx at 0, 0? Would be 6. What's fyy at 0, 0? Minus 6. So that doesn't tell me anything. I have to do the d. The d is you take fxx times fyy minus fxy squared. So you take the 6 times the negative 6, and fxy at any point would be 0. 6 times negative 6 is negative 36. When d is a negative number, that means this point was a saddle point. So if you test a point and it gives you in this equation a negative number, then it's a saddle point. So let's test 0, 2. I'm gonna test equation at 0, 2. Same steps. Let's see if 0, 2 is a maximum or a minimum or a saddle point. You find xx at 0, 2. At 0, 2, that would be 6. We try fyy at 0, 2. 2 here would be 12 minus 6, 6. And we try the d. fxx, fyy, fxy squared. That would be 6 times 6 minus 0 squared. That's 36. That's over 0. Again, when d is negative, it's a saddle point right away, regardless of what happened here. If d is positive, you check the answer. Positive. Everything positive means that this point was a relative min. So if d is positive and both of them positive, relative min. Let's try negative 2 and 0. So again, we do fxx, fyy at minus 2, 0. Minus 2 here will give you negative 12 plus 6, negative 6. Negative 2, 0, 0, and y will give you negative 6. And then we do the d. fxx, fyy, fxy squared. fxx would be negative 6 times negative 6 minus 0 squared. That's 36 over 0. Again, d negative, saddle point. D positive, you look, everything positive, relative min. But this is positive and these two negative, then this point is a relative max. D positive and this negative, relative max. And the last point, minus 2, 2. So we do the fxx, the fyy. A minus 2 gives you a negative 6 here. A positive 2 here gives you a positive 6. And then we do the d, fxx, fyy, fxy squared. Negative 6 times 6, 0 squared, negative 36, less than 0, saddle point. And the other condition, I doubt that you'll see in the exam, but what if d is positive, is 0? If d is 0, means that it's inconclusive. We don't know what this point is. So it's three cases: negative, saddle point; positive, everything positive, minimum; positive and these two negative would be relative max. I'm gonna do worksheet B. Pretty much the same questions, but extra practice doesn't hurt. The first question was find the equation of the tangent plane, and you're given the information. So this is similar to the first question. The only thing different is it's implicit differentiation. So we know that the equation says it's the derivative with respect to x minus point, derivative with respect to y minus point, and z minus z0. That, like the same thing I did with the first question. So I need to find fx, which is the derivative of d with respect to x. And there was a formula for the implicit differentiation. Negative, you find fx, or the function derivative, and you find fz. So, to do this, where is the equation? Okay, derivative with respect to x would be 2x, 0 for the second one, 0, and then minus z, and the derivative with respect to z in the bottom, yz derivative is y, then minus x, then 2z. And you also do the dz over dy, fy, fz. Now the bottom is the same, doesn't change. Derivative of the equation with respect to y, x squared is 0, yz derivative is z, and then 2y. The point that we need to plug is 1, 2, 1. So plug 1, 2, 1 in both of these. In the first one, we'll give you 2 minus 1, that's 1. Here it would be 2 minus 1, which is 1, plus 2z, so that's 3. So the first one will give you negative 1/3. If you plug this point into this, it would be 1 plus 4, 5, and the bottom is 3. Then you go the surface. We did the derivative. X minus the point, we did the derivative, y minus the point, minus z minus z0, which is 1. This is the equation of the surface, tangent to the surface. Question, well, you can leave it as it is or work it out. Doesn't matter, just leave it like it is. Question 2. So, in question 2, linear approximation, similar to question 2 in worksheet 6a. So the function is x squared square root 1 plus y squared, and use it to approximate 1 plus 0.2 squared. Okay, and use a point close to this. So a point for x close to this would be 1, and a point for y close to this would be 0. So we're going to use 0.10. As we did in the first question in the worksheet A, you find the derivative of x. That would be 2x root. We find the derivative with y, so we imagine having exponent half x squared 1 plus y squared negative half derivative of the inside to y. Then I'm gonna plug this. So I'm gonna find fx at 1, 0 and fy at 1, 0. 1 and 0 here will give me 2. 1 and 0 here, since this is 0, everything will turn into 0. I also need to find the value of the function. As I told you, you need the derivative of the function at the point, derivative with respect to y at the point, and the value at the point. When you plug 1 here and 0 here, this will give you 1. So your linear approximation, you put the value, you put the derivative of x minus whatever the point of x, the derivative of y minus the y. So it's 1 plus 2x minus 2, it's 2x minus 1. So that's your linear approximation, 2x minus 1. What's the value of this at 1, 1? That's the B answer. At 1, 1, it would be 2 times 1, 1 minus 1, 2.2 minus 1, 1.2. So that's roughly what the answer is for the linear approximation. I'm gonna stop this part. I'll finish worksheet B, and I'm also gonna talk about the midterm briefly. So I'm gonna stop this and do the third part.